We're going to take a pause on these verifying problems for a moment. We'll circle back to them again next week, but I want to talk a little bit about solving, as that's the other topic here, this chapter. So prior to this, you had been able, right, we had asked you to do things like solve sine theta equals 1/2, where, theta is between pi over 2 and 3 pi over 2, right? So what you went and did is you went to the unit circle, you went to look for where y is equal to 1/2, and you looked in this area. And when you do that, if you guys can pull out your unit circle, it's on the back of your identity sheet that we've just been using recently. Where do you see that y at? Y equals 1/2. From pi over 2 to 3 pi over 2.
5 pi over 6.
Good. And we're done, right? Just like a chapter 4 problem. So one thing that we're going to change here in chapter 5 we're going to solve over some bigger intervals. So what if we consider all of 0 to 2 pi? Same problem. Go to my unit circle, look for where y is equal to 1/2. But now I'm looking on the entire unit circle. So not only do I have 5 pi over 6, I also get pi over 6. That's the other place where the y coordinate is 1/2. So we're going to start getting the possibility of more than one answer. Is everybody okay with that idea? So far, so good? Okay. Now, the other thing that we're going to start introducing is you're going to have to do some solving to get the trig function by itself. So here we have cosine squared x equals 1. For me to go to the unit circle, though, I have to have that cosine by itself, right? So what do I have to do to both sides of this equation to do that? So square root both sides, okay? Now when we square root both sides of an equation, what do we have to remember? A plus or minus. So now, when I go to my unit circle, I'm going to be looking for where x is equal to 1 and also where x is equal to -1. So go look on your unit circle and find the places where x is 1 or -1. Okay, 0, pi, and keep in mind right here it says or equal to 2 pi, and 2 pi and 0 are the same, are coterminal. So 2 pi should count in this case also, right? As you travel all the way around the unit circle, 2 pi is at the same spot as 0, so it'll have the same point. And 2 pi is an allowable answer because it's an or equal to inequality at the 2 pi. Everybody okay with that one? So there we got 3 answers. So start by dividing by 3. Very good. Then what? Square root both sides. Good. Oh my goodness, what I do here? It's 1/3. Remember when we square root both sides, we need a plus or minus. Now, how do I square root a fraction? It's an Algebra 2 question. We did this you did this last year. Hopefully you remember that, right? So you can square root the top. What's the square root of 1? And then the square root of the bottom. Well, can't do anything with square root of 3, just square root of 3. Well, you could rationalize it, but this is not going to be a final answer, so like I'm not going to waste my time doing that. You could, it's not wrong to do that, but we don't need to. Our final answer is going to be an angle measure without a radical in it anyways. Well, I'm just not going to bother. Okay with that reasoning? So in the unit circle, what is tangent? Y over x, right? So you might think this, right? But I don't see any points on the unit circle that have an x-coordinate square root 3 and then a y-coordinate of 1. Yeah, but if you look at your unit circle, you do see places where the y-coordinate is 1/2, 1/2, and place where the the x-coordinate is square root 3/2. So we can do something like that. And now that's something I can find on my unit circle, right? So how many answers should I be getting here? 4. So positive x, positive y, positive x, negative y, negative x, positive y, negative x, negative y. So 4 answers, right? What are those 4? Where x is plus or minus root 3/2 and y is plus or minus 1/2. Okay. Yeah, okay. 11 pi over 6, and then the last one is pi over 6. So this is both of them positive. This is x is positive, y is negative. This is both of them negative. This is x is negative, and then y is positive. Just if you're like, where did you get those? That's where Joey pulled them from. Interesting order, but it worked. That there's no preference given for the order of our answers. You just need to have our answers. Okay. So far, so good. Okay, what if we have 2 tan x sine x equals tan x? What do we want to do to solve this one? So it's tempting to want to divide by tan, right? But there's a problem in doing that. What's that? It's connected to the sine. That's not so much the problem, because like the 3 was connected to the tangent up there, and we divided by 3 there. Tangent x is a variable, right? So potentially, what value could that variable have? 0. Can we divide by 0? No. That creates a problem. We're going to lose potential solutions here if we do this. Never, ever, when you're solving, divide by a variable. Okay? So that's a normal first idea. Not what we want to do ever when solving. Okay? Not just in trig, but in algebra, any other math class, never divide by a variable. Bad things happen. Instead, the way you'd want to approach this problem is the same way you approached solving a quadratic or polynomial last year in Algebra 2. So what was the first thing you did to solve a polynomial equation? What does it have to equal? 0. Let's do that as our first step. So we're going to subtract tan x from both sides. Is tan x and then 2 tan x sine x like terms? No, so I can't combine them. I just have to write it next to each other, right? Everybody okay so far? Okay, back to Algebra 2. Your quadratic is now equal to 0. What do you do to solve it? To what end, though? What is synthetic division going to get you? That's if you're solving a polynomial, you could certainly use that as a method. But the reason that's working is because of what's it allowing you to do? You're on the right track for sure. You're just a little bit too specific. So say you had x squared plus 4x plus 4 equal to 0. Right, just like some quadratic. What are the ways that you can use, what are the ways you can solve that? Factoring. That's what we're going to do here. So if I look at 2 tan x sine x minus tan x, what kind of factoring is available to us? Doesn't look quadratic to me, but there is another type of factoring. Imagine if you had x squared minus 2x equal to 0. How would you factor that? You take out a greatest common factor of x. Exactly. What is our greatest common factor here? It's not 2x. It's not just x. X is locked inside of the trig functions. It's tan x. Because each term, the 2 tan x sine x is one term, and then the negative tan x is another term. Both contain a factor of tangent. Can you guys see that now? Yes. Okay. So if I factor that out front, what does 2 tan x sine x become? Becomes 2 sine x minus 1. Because remember, when we're factoring this out, what are we doing? It's like dividing, right? So we divide tan x by the first term, the tans cancel. Leaves you with just 2 in sine x. We divide the second term, everything cancels, you're just left with 1. Is everybody okay there? So now you factored through a quadratic. You have 2 parentheses, whole thing's equal to 0. What do you do then? So you have go back to algebra 2, you have your 2 quadratics that are equal to 0, or your 2 factors equal to 0. What? I'm sorry, you find the zeros. How? Well, there's nothing added, right? You just have 2 things multiplied together. You have these 2 parentheses multiplied together. Now there's stuff inside of them, right? There's something like that. What do we do next to solve this? If you FOIL it back out, you're just back at the quadratic that you started. So think about it this way. You have two things that you're multiplying together. The product is 0. What can you say about one of those two things? At least one of them has to equal 0, right? Yes, that's exactly what you want to do. So what that's called is the zero product property. It says if you have, like a bunch of factors that all multiply together and give you 0, at least one of those factors must be 0. So if we apply the zero product property here, we can say tan x is equal to 0, and 2 sine x minus 1 is equal to 0. Is everybody okay there? All right. Now this first piece is ready to go to the unit circle because we just have a single trig function. Again, tangent is y over x, and that has to equal 0. Can we write 0 as a fraction? Sure you can, right? Not 0 over 0, that's indeterminate. 0 over, I would use 1, because now you're looking for x equals 1, y equals 0 on the unit circle. So x here, I should not have used x. But I'm going to go back and change this to like a theta or something, because now I'm getting myself confused because I got x's on the unit circle and x's in my equation. I'm just going to change the name of that variable to be something less annoying. You guys okay with that? You see why it was going to get confusing there for a minute? Because now I'm about ready to write x equals again, but now it's a new number. It feels dumb. So x equals 0, and 2 pi would be the other one, right? Pi doesn't work because the x at pi is -1, right? Now, should that count? Is 0 divided by -1 still 0? Yeah. So really what I care about is just looking for where the y coordinate is 0, right? At the end of the day, that's all I really cared about. So let's look at our next part. 2 sine theta minus 1 is equal to 0. What am I going to do first? And then? Okay, add 1 and divide by 2. It's our old friend sine 1 over 2. We've seen that like 3 times now today. I go to my unit circle, looking for y equals 1/2. What are my angles I find? 5 pi over 6 and pi over 6, right? So my answer would be all 5 of those. Does this feel okay? Not bad, right? Very similar to the things we did in chapter 4. We just have to do a little bit more work till we're ready to go to the unit circle. And then we can pull multiple answers from the unit circle. But that's fine. It's still like basically the same process. They're a little bit maybe more in front of it, a little bit more pulls from the unit circle, but it's still, that core procedure is still the same that we did last chapter. This is where I'm stopping. What I'd like for you guys to do today is I have a delta math assignment for you. Do this real quick as an example. So you guys have 3 types of problems, or kinds of problems here. So one might be what we were just doing. Come on. So if I have something like root 2 cosecant x, and I'm going to use theta here, equals -2. What would I do first? Yeah, I'm going to just divide by root 2. Now the trig function is by itself. So if I go to the unit circle, what is cosecant? So the reciprocal of sine, which means it's 1 over y. Or probably more practically, I'm just going to flip both of them and do that, right? Is everybody okay with that? Well, if I'm going to the unit circle, it's much easier to look for y than 1 over y, right? Yeah. That's the only reason I flipped it. Just to make it more convenient for me on the unit circle to search for this thing. So I'm going to go to my unit circle. I'm going to look from 0 to 2 pi. And I'm going to look for the places where the y coordinate is negative root 2 over 2. What do you guys see? 5 pi over 4 and 7 pi over 4. So into my delta math, I'm going to do 5 pi over 4, and I'll hit a comma. It'll give me a space to put a second answer. Every time I press comma, it'll give me another space for an answer. So 5 pi over 4, 7 pi over 4, I hit yes. Those are my answers. And there's one down. You gotta do 5 of those. Let's do, the other one is some of these simplifying problems. So here it asks to simplify to a single trig function with no denominator. So I'm going to be using my identity sheet here, and then maybe some algebra things. So I start off with cosecant times tangent. So I can look for an algebra thing, but I just have two things multiplied together. They're not like terms. There's really nothing I can do with this algebraically. So I'll go to my identity. I'm going to look either for a way to turn cosecant into a tangent or a way to turn the tangent into something with a cosecant in it. So I'm just going to look at my identity sheet and see what I can do. Where on my identity sheet am I probably going to be looking? R's and Q's, right? Since everything is to the first power, that's typically the place where I'm going to live, are those R's and Q's. If I don't have anything squared, it's unlikely I need to use a Pythagorean. And the other ones I would only use if the variable is not identical. Like if I had a negative theta inside of one, or a pi over 2 minus theta inside of one, but I don't have that, so I'm not going to look at any odd evens or cofunction. I'm going to use Q1. What am I going to rewrite tangent as? Secant over cosecant. What do I notice I can do then? So I'm left with just secant. That's what I'm going to type in. Done. You gotta do 10 of those, but they're gonna be simple ones like that, where they're probably just one identity or two identities. Okay, and then the last one is just like a practice using your identity. So it says which function is the equivalent to 1 over cosecant. This is all gonna be reciprocal things, right? So 1 over cosecant is the cosecant is reciprocal of sine. So 1 over cosecant has to be sine. Done. You have to do 10 of those. Those should be quick, right? They're just using the reciprocal relationship. So the remainder of class, you can work on these delta maths. Or if you'd prefer, you can work on the 47 to 62 that we had started last class. Either is fine. Everybody clear as to what to do, Alondra? I can look it up in just 1 second. I don't have it right in front of me.